before it reaches you. Right now, without asking your permission, you are looking at the past. Every star overhead, every patch of glow you've ever called the sky, arrived already old. Some of it older than agriculture, older than language, older than the idea of looking up at all. A few of those points of light may not even exist anymore. Nobody has told them yet. There is a version of this that happens closer to home too, one most people never notice because it's too small to feel. The face across the table from you right now is not technically happening in real time. It's arriving, late, always late. Just late enough that now was never really available to either of you, only ever a very good approximation of it. Somewhere in your own life there was a moment you swore was instant, a glance, a reaction. At the second I saw it, I knew. And it wasn't instant at all. Nothing ever is. There is a number that sounds made up until you sit with it. 8 minutes and 20 seconds. That is how old the sunlight touching your skin already is by the time it gets there. Not from this morning, not at all. Not from an hour ago. From 8 minutes and 20 seconds in the past. Every single time without exception, for as long as either of you has existed. You're not looking at the sun. You're looking at where the sun used to be pointing. Somewhere, right now, a person is falling in love with someone who's already gone, and they don't know it yet, and they won't know it for years, and that is not a metaphor. That is just what happens when you look up. Here is the strange part nobody ever really warns you about ahead of time. The delay never stops, not for a second. It doesn't close. You don't catch up to it by living long enough, or by travelling fast enough, or by wanting to badly enough. The gap between when something happens out there and when it reaches you is permanent, built into the room itself, and there is nothing you can do to shrink it. Some part of you is always looking at the past and calling it now. That is where this one starts. Not with a planet, not with a telescope. With the simple, almost rude fact that nothing you see in the sky is happening. It already happened. You're just now finding out. Distance does something to time that most people never think about, mostly because they never have to. Not once, not in an ordinary day. You wake up, you look outside, the world seems to be occurring in real time, all of it stitched together into a single present moment. But that stitching is an illusion your eyes are running for you, quietly, without asking permission. The light bouncing off your coffee cup took a few nanoseconds to reach you. The light from the street lamp took a little longer. The light from the moon took just over a second. None of it announces its age. It all just arrives, and you assume it just happened, because that is easier than doing the math every time you open your eyes. The math gets stranger the further out you go. Not stranger in the sense of harder. Stranger in the sense of unsettling. The way it's unsettling to learn a photograph you've been looking at your whole life was taken before you were born. Light moves at a fixed, unbending speed. It cannot go faster no matter how much distance it has to cover, which means the greater the distance, the greater the delay, and the delay is not small once you get far enough out. A star 4 light-years away shows you itself as it was 4 years ago. A star 4,000 light-years away shows you itself as it was 4,000 years ago, before most of the languages spoken on Earth today existed at all. You could be looking directly at a star that no longer exists, that finished burning, collapsed or exploded long before your grandparents were born, and it would still be sitting there in the sky tonight, glowing, patient, several thousand years late with its own obituary. That is not a special case. That is just how looking at anything far away works. You are never seeing the thing. You are seeing the light it sent out, a long time ago, still in transit, only now completing its trip. This star, whatever it's doing right this second, is not who you're looking at. You're looking at its mail, sent a very long time ago, only just now being delivered. Sit with that for a second before moving on. Some of what you're looking at up there isn't there anymore. Some of it isn't there yet. Both of those things are true at once, in the same sky, and the sky doesn't sort them for you. It just presents them side by side and lets you assume they're all happening together, because it runs both directions. Somewhere out past what any telescope has managed to reach, there are events that are happening right now in this instant that nobody on Earth will know about for centuries or millennia or longer than that. Not because the events are hidden, but because the news hasn't had time to arrive. The universe isn't holding anything back on purpose. It's just that information has a speed limit, and reality from where you're sitting is always a little behind schedule. Think about what that means for a supernova. Somewhere in a galaxy we can already see, a massive star may be in its final hours right now, burning through its last fuel, its core beginning to buckle under its own weight, and we will not know. We will not see so much as a flicker. Not tonight, not next year, not for however many thousands of years it takes that light to make the crossing. The star could already be gone by any reasonable definition, and the sky will keep insisting otherwise for a very long time, because the sky is not lying, it's just late. There's a particular kind of quiet that comes from realizing how much of what reaches you is already old news, dressed up as breaking news. The light from anything more than a few miles away has already made a journey before it touches your eye. Even the light from across a room took a small, real amount of time to travel that distance. So technically, and this part tends to unsettle people the first time they hear it, you never see anyone exactly as they are. You see them as they were, a fraction of a second ago, packaged into light, sent your way, and only just arriving as you register their face. At room distance, the delay is so small it might as well not exist. But the principle doesn't change just because the distance shrinks. It's the same rule, the same physics, whether you're looking across a kitchen or across a galaxy. Only the size of the delay changes, not the fact of it. It's a strange thing to try to hold in your head for very long, this idea that scale doesn't break the rule, it just stretches it. A nanosecond and a millennium are, in this one specific sense, the same kind of gap, obeying the same law, built from the same stubborn ceiling on how fast anything is allowed to travel. Nothing about crossing a room is fundamentally different from crossing a galaxy. There's just a great deal more room to cross, which brings back the 8 minutes and 20 seconds. That number isn't dramatic. It's not chosen to be alarming. It's just what the arithmetic gives you when you divide the distance between here and the sun by the fixed speed at which light is permitted to move. 93 million miles, roughly, divided by a little over 186,000 miles per second. 8 minutes and 20 seconds, give or take, every day, for as long as you've been alive, for as long as anyone has been alive, for as long as there has been an Earth positioned at that particular distance to receive it. If the sun simply stopped, not exploded, not dimmed, just vanished from existence in an instant, you would not know for 8 minutes and 20 seconds. The sky would look completely normal, Warm light would still be reaching your skin from a source that technically no longer existed. Birds would still be flying by what looked like daylight. And then, 8 minutes and 20 seconds later, and not 1 second sooner, everything would change at once. Because that's precisely how long the good news, or in this case the very bad news, takes to travel. Nobody would get an early warning. There is no version of this where a faster signal slips ahead to alert you. Nothing outruns light. Nothing gets there first. Whatever leaves a source, however important, however urgent, travels at the exact same fixed pace as everything else that has ever left that source. Urgency doesn't buy speed. Distance is not negotiable. The delay is the delay, applied evenly, without favoritism, to every photon that has ever set out on a journey toward an eye. There's something almost comforting buried inside something that unsettling, if you sit with it long enough. The delay means you are, in a very literal sense, connected to the past every time you look up, not remembering it, not imagining it, receiving it directly as light, still arriving, having never stopped arriving since it left. The past isn't gone. Some of it is simply still in the mail, and some of what's in the mail hasn't been picked up yet. Somewhere between here and wherever it started, there is light right now, mid-flight, belonging to an event you've never heard of, heading toward you or past you or nowhere near you at all, on a schedule nobody controls and nobody can rush. There's another layer to this that I only half understand, even now, even after sitting with it for a long time. The light doesn't just arrive late, it arrives changed. As space itself stretches during the long crossing, the light stretches with it, shifting toward longer, redder wavelengths, a phenomenon astronomers simply call redshift, though the name undersells what's actually happening. The light isn't just old by the time it gets to you. It's been altered by the very distance it had to cross to reach you at all, worn down in a specific, measurable, honest way, like a voice that's travelled through enough rooms to lose its original edge. The farther out you look, the redder that stretch becomes, until at the outer edges of what we can detect, ordinary visible light has been dragged so far down the spectrum that our eyes can no longer register it at all. It has to be caught by different instruments, translated, brought back into a range we're built to notice. What left as one kind of light arrives as another kind entirely. Not because anything about the light lied to us, because the space it crossed was never standing still, and the crossing itself left a mark. I keep circling back to how ordinary this feels once you stop being startled by it, and how strange it becomes again the moment you stop to actually picture it happening. A beam of light sets out from somewhere impossibly far, and for the entire unthinkable length of its journey, nothing observes it. No one watches it travel. It simply crosses, alone, unattended, for longer than civilizations tend to last, until one day it happens to intersect a particular retina on a particular planet, and only then does it become information to anyone. Until that moment it was just travelling. Not for you, not for anyone. Just travelling. Because that is the one thing light does without needing a reason. Some of it never arrives anywhere at all. It simply keeps going, forever, missing every eye, every lens, every possible witness, drifting through the enormous, mostly empty in between, part of a journey that has no observer and never will. We tend to assume that if something happens, someone eventually finds out. Out there, that assumption quietly stops being true. Most of what has ever happened in the universe will never be seen by anyone. It's not lost, it's just uncollected. And then there's the part that's harder to sit with, because it points a finger back at the one doing the looking. If everything you see is old by the time it reaches you, then the present moment, the one you keep assuming you're standing in, isn't really a place you can ever fully occupy. It's always just out of reach, one step ahead of whatever version of it you're currently receiving. You live permanently a few moments, or a few minutes, or a few thousand years behind whatever is actually happening around you. Not because anything is wrong with you, because that is simply the deal light offers, and it has never once offered a different one. Maybe that's the part worth sitting with the longest, longer than the sun, longer than the redshift, longer than any of the numbers. Not that the universe is old, not that it's large, but that now, the thing you've spent your entire life assuming you had full access to was never fully yours to have. It arrives in installments slightly late every time, and there's no version of paying it off early. You did not do anything to deserve this delay, and you cannot do anything to end it. It was built into the room before you arrived in it, and tonight, whether you notice or not, you'll be standing underneath a version of the sky that hasn't finished happening yet. The weight of something not yet arrived. Somewhere out past anything you could name, two enormous, dark, very ancient objects are about to finally touch. Not colliding yet, not by a long way, not yet. Just close enough now, finally, that the space between them has started to hum. Faster and faster, the way a coin spins right before it finally settles flat. In a moment, cosmically speaking, a moment that could still turn out to be centuries by the time it ever reaches anyone at all, they will merge into one, and the universe around that spot will ring like a struck bell. It hasn't happened yet. It's about to, and about to out there can last longer than your entire species has existed. I want to say something confident about gravity, and I can't. Not entirely, because even the people who study it for a living, the ones who've spent whole careers inside this particular question, will tell you, quietly, off to the side of a conference somewhere, that some of this still unsettles them too, and that they haven't fully made peace with it either. Here's the part that's easy to accept. Gravity pulls. You already knew that. Drop something, it falls. Simple, familiar, boring, in the best way. But here's the part that took physics a very long time to accept, and that most people never hear at all. Gravity doesn't pull instantly. It isn't some invisible hand reaching across all of space at once, touching everything simultaneously the moment a mass exists. It has to travel. It has a speed. And that speed, as strange as this sounds, is exactly the same speed light travels at. Not similar, not close, the same. Which means if the sun's mass were somehow removed this instant, not its light, its actual gravitational pull on the Earth, you would keep orbiting undisturbed for the same 8 minutes and 20 seconds it would take the darkness to arrive. The gravity wouldn't beat the light there. It wouldn't lag behind it either. They'd arrive together at the same pace, like two messengers who left at the same time and have never once been allowed to walk faster than one another. Sit inside that for a second. Gravity is not the instant thing you assumed it was, and it never has been, no matter how solid and immediate it feels every time something falls in front of you. It's a signal. It has to travel the distance, the same as anything else, and until it arrives, whatever it's carrying simply hasn't happened yet. Not for you, not from where you're standing, no matter how finished it already is somewhere else. Now go back to the two dark objects, still about to merge. their spin tightening, their pull on each other sharpening into something almost unbearable. When they finally touch, when whatever is left of them collapses into a single, heavier, quieter thing, they'll not simply announce it to the universe instantly. The announcement itself has to be built and sent, and the way it's built is strange enough that it barely sounds like physics at all. It comes as a ripple in space itself, a genuine, physical, stretching and squeezing of the distance between things, radiating outward in every direction, forever, getting fainter, but never quite stopping. That ripple has a name now. Astronomers call it a gravitational wave, and until fairly recently nobody had ever caught one directly, only inferred that they must exist, because the math insisted on it, and reality tends to follow the math whether or not anyone has built the right instrument yet to check. When one of those ripples finally does reach a place like Earth, it doesn't arrive the way you might picture it, with force, or sound, or anything your body would notice on its own. It passes directly through you, through your bones, your chest, the room you're sitting in, the whole planet without asking, without resistance, stretching and squeezing everything it touches by an amount so small that even our best instruments can only just barely catch it. A distance the size of a few thousand kilometers gets adjusted by less than the width of a single proton. You have almost certainly already been passed through by one of these, more than once, and felt absolutely nothing, because there was nothing to feel, not at a scale your senses were ever built to register. I find that part strange in a way I don't think I've fully worked out yet, that something can be real, physical, verified, currently moving through your body as you read this, and still be completely and permanently unnoticeable to you. The merger that made a given wave might have happened 1 billion years ago. Whatever civilizations existed anywhere near it, if any did, never got a say in when the signal would leave, or how long it would take, or who would eventually be standing somewhere far away, quietly, holding an instrument sensitive enough to notice a stretch the width of a proton. The wave left when it left, indifferent to anyone waiting on this end of it. It arrives when it arrives, and not a fraction of a second before that. Nothing about your readiness, or your instruments, or your interest, or how badly you might want to be told sooner, moves that schedule even slightly, not by a single second, not for anyone. There's a strange kind of patience built into gravity that I don't think we give it credit for. It doesn't rush its announcements. It doesn't front-load the news. Something enormous can happen, and the universe simply lets the consequences travel outward at their own fixed, unhurried pace, arriving everywhere eventually at the correct time and not one moment sooner, the way sunlight always arrives 8 minutes late and never asks to be forgiven for it. For a long stretch of the last century, this was only a prediction, sitting quietly in the mathematics of general relativity, unconfirmed, waiting on the universe to volunteer proof of its own accord. Physicists found an indirect kind of evidence decades before they found a direct one. A pair of dead, dense stars orbiting each other, spiraling slowly, measurably closer over years of careful observation, losing energy at precisely the rate you'd expect if that energy were being carried away as ripples, unseen, radiating outward the whole time. Nobody caught the ripple itself. They caught its fingerprint, left behind in an orbit that kept quietly shrinking, exactly on schedule, exactly as predicted, decades before anyone built an instrument sensitive enough to feel the wave directly. It wasn't until 2015 that anyone actually did. 2 long tunnels, each several kilometres of nearly perfect vacuum. Laser light bounced back and forth along their lengths with a precision that still sounds almost impossible to describe honestly. And through those tunnels passed, for a fraction of a second, the tail end of a wave that had been travelling for well over 1 billion years, the leftover ringing of 2 black holes finally completing a merger that had been building since long before anything resembling a human eye existed anywhere to notice it. The instrument didn't hear an event. It heard the arrival of an event delivered late on its own timetable, the way everything eventually arrives if you're patient and precise enough to be standing in the right spot when it does. Consider this too, because it sits close to the same idea from a slightly different side, one worth turning over on its own. Right now, somewhere, there may already be a gravitational wave in transit toward Earth that nobody has predicted, carrying the imprint of some collision or collapse we haven't even detected yet through any other means. It's real. It's happening. It is, in the fullest physical sense, already true, and it simply hasn't gotten here. That's a strange category for something to sit in. Already true, not yet arrived. We don't have very good language for it, because most of what we're used to either has happened or hasn't. This sits in between, technically finished, technically still en route, both at once, for as long as the distance demands. I think about the merger itself sometimes, the actual moment of it, and how strange it is that moment barely applies. 2 black holes spend their final seconds together spinning faster than anything has any right to spin, faster and faster, closing the distance between them until there effectively isn't one left to close. And then, for a fraction of a single second, more raw energy gets released in the form of these particular ripples than every star in the observable universe is producing in visible light, combined. Not metaphorically more, actually more, briefly, for less than a second, from an event involving nothing you could ever point a normal telescope at, because none of it was ever made of light in the first place. None of that brightness, if you can even call it brightness, ever reaches an eye. There's nothing to see. The entire event is gravitational, not luminous, which means the only way to ever know it happened at all is to feel it, indirectly, through the stretching of space itself, measured by instruments built specifically because human senses were never going to be equal to the task. I keep circling this from different angles, over and over, and I honestly don't think it resolves into anything tidier the more times I do that. The distance itself is the thing holding the event in place, more than time is. It isn't waiting. It isn't being delayed by anyone's decision. It is simply still covering ground at the one speed the universe allows, indifferent to whether we're ready for it, indifferent to whether we ever will be. There's a word in the chapter's own title I haven't really earned yet, and it deserves a moment before this closes. Wait. Not wait the way you feel it standing on a scale, but wait as the actual bending of the space around a mass, the dent a heavy object leaves in the fabric, everything else is forced to move through. Every planet, every star, every one of those 2 dark objects, circling each other before their merger, presses a kind of hollow into space itself, and everything nearby has no choice but to follow the curve of that hollow, whether it calls the following falling, or orbiting, or simply staying. That hollow is not instantaneous either. It has to be built, communicated, updated, at the same fixed pace as everything else, 1 photon's worth of speed at a time, no faster, regardless of how heavy the object making the dent happens to be. So even the weight of something, the actual gravitational shape it presses into the space around it, is itself a kind of message, composed and sent, arriving only once the appropriate amount of time has passed. Nothing about mass gets to skip the line, not even the heaviest things anyone has ever found. And when it finally does arrive, whichever wave, whichever merger, whichever old, dark, patient collision, it will pass through you exactly the way the last one did, silently, completely unnoticed, already true for a very long time before it ever became, in any way you could feel, yours. Rooms with no one home. People say the observable universe like it's a modest phrase, almost apologetic, as if it's just a polite way of admitting we haven't looked everywhere yet, haven't gotten around to it, haven't finished the job. It isn't that. It's not a placeholder for ignorance. It's a real boundary, with a real number attached to it, and the number is stranger than the phrase makes it sound. Here's the part worth pausing on before going further, because most people skip past it too quickly. The observable universe is not the universe. It never claimed to be, not once, not in any careful definition of the term. It's the part of the universe whose light has had time to reach us since everything began. Nothing more, nothing less, and definitely not everything there is. Picture a house at night, every window lit, warm yellow light spilling out onto a dark lawn, and yet, if you actually walked up and looked inside, no one there. Not empty in the sad way. Empty in the administrative way, the way a stage looks after the actors have already left, but the lights are still on a timer. Some regions of the visible sky work like this. The light arrived. The light is doing exactly what light does, faithfully on schedule. But whatever produced it, whatever galaxy or star sent it on its way, may no longer be sitting where the light suggests it is, or may not even exist in the form that light describes anymore. The window is lit. The house has already changed hands or burned down, or simply gone quiet, and none of that has caught up with the light yet. I've come back to this idea more than once over the years, and it still rearranges itself slightly every time. The way a familiar room looks different once you've learned something new about who used to live there. Consider the actual shape of what we call observable, since the shape itself turns out to matter more than the name suggests. It is, by one careful measure, a sphere roughly 93 billion light-years across, with us sitting more or less in the middle of it, not because we're special in any particular sense, but simply because observable is always defined relative to whoever's doing the observing. Move the observer, and the sphere moves with them, centered wherever they happen to be standing. Every civilization anywhere, if any others truly exist out there, gets its own sphere, its own guest list, its own edge, somewhere far out there. That number tends to confuse people the first time they hear it, because the universe itself is only about 13.8 billion years old, and yet the observable sphere stretches out to roughly 46.5 billion light-years in any direction, not 13.8. That isn't a contradiction, and it isn't sloppy math. It's what happens when the space the light is travelling through has itself been stretching the entire time the light has been in transit. The light left a source that, at the moment of departure, was much closer to us than it is now, because the fabric connecting the two of us has been quietly expanding underneath the whole journey, carrying the source further away, even while its light kept heading our direction at a fixed, patient speed. By the time the light finally arrives, the place that sent it is no longer there. It has drifted, riding the expansion, into a further, newer position, one the ancient light knows nothing about. So every point of light in the sky is doing something slightly deceptive, not out of any intention to mislead, but simply because it's reporting from a version of reality that's already gone. The house at night, still lit, still standing in the picture, has since been renovated beyond recognition, or torn down, or replaced with something else entirely, somewhere out past what the light bothered to mention. There's a second, quieter layer to this house, one that troubles me slightly more than the first, though I'm not sure I can fully explain why. Some houses out there have never been lit at all, not because nothing lives in them, but because their light hasn't had time to reach this particular street yet. They exist. They're occupied, presumably, by whatever ordinary physics is doing wherever they happen to be. It's simply that no messenger has arrived from them. Not yet. Not for a very long time still. Possibly not ever. The universe is enormous enough, and light is slow enough relative to that enormousness, that entire neighborhoods can sit in genuine darkness from our vantage point indefinitely, purely as a matter of geometry and time, with nothing sinister behind it at all. And there's a third kind of house, the strangest of the three, that I think about even more than the other two. This is the house whose light will never reach us, not because the distance is too great to eventually cross, but because the distance is actively growing faster than the light can close it. Space itself is not just stretching gently. The rate at which it stretches is, on the larger scales, accelerating, driven by something cosmologists label dark energy, mostly because they need a name for the effect, and don't yet have a fuller explanation for the cause. Past a certain distance, called the cosmic event horizon, galaxies are receding from us faster than light itself can make up the ground between here and there. Their light sets out sincerely, correctly, at full speed, and simply never arrives, forever falling short, the way a runner might sprint toward a doorway that keeps sliding further down the hallway, at a rate the runner can never quite outpace. That's not a hypothetical for some distant future either. It's happening now to real galaxies, some of which we can currently see, whose light is already stretched thin, dimming, reddening, on its way toward a point where it will effectively vanish from our sky, not by moving away in the ordinary sense, but by the space between us simply refusing to stop growing. The dimming itself follows a pattern you could, if you wanted to, actually chart. As a galaxy nears that horizon, its light doesn't switch off abruptly, the way a bulb does when a switch is thrown. It fades the way an ember fades, gradually, the wavelength stretching longer and longer, sliding out of the visible range entirely, first toward deep red, then further into infrared, then further still into wavelengths no eye, however patient, was ever built to register. Even after the light becomes technically undetectable to us, the galaxy hasn't stopped existing. It has simply moved fully out of the conversation, permanently, the way a voice fades below the threshold of hearing long before the person speaking has actually stopped talking. There's something almost tender in that image, if tender is an allowed word for something this vast and this indifferent. A galaxy doesn't get cut off. It gets quietly, gradually, unheard, the way the last few words of a sentence sometimes get lost if the person saying them turns slightly away before finishing. I think about the middle category the most, out of the three, the houses that exist but haven't been lit for us yet, because that one feels the least like an ending and the most like an ordinary, unremarkable form of waiting. Nothing dramatic is happening to those places. They are not fading. They are not gone. They are simply, patiently, still in transit, obeying the same fixed speed limit everything else in this story obeys, arriving on a schedule that has nothing to do with anyone's curiosity about them. Some of those unlit houses may never be lit for us at all, not because the light is too slow exactly, but because the expansion carrying them is quietly outpacing the light before it ever gets the chance to close the gap. Others may eventually arrive, centuries or millennia from now, their light finally completing a crossing that began before anyone alive today existed to wonder about it. There is no way, from here, to sort the two groups apart. Both look, from this side, identical, simply dark, simply unlit, simply absent from the record so far. It's worth sitting for a moment with how ordinary this all feels, once you stop being startled by it, and how strange it becomes again the instant you try to actually hold the picture whole in your head. Every glance upward is a glance across 3 different timelines pretending to be one. Nothing about the light rearranges itself to make this easier for you. It simply arrives, all of it together, indistinguishable at a glance, and leaves the sorting, if any sorting happens at all, to whoever bothers to ask which house is which. The idea of a horizon usually implies you could, in principle, walk toward it and eventually reach it, the way a horizon on the ocean recedes but never actually escapes you if you keep the boat moving. The cosmic event horizon doesn't behave that way. It isn't receding because you're approaching it. It's receding because the space itself, everywhere, all at once, is expanding, which means the horizon moves away from every observer simultaneously, regardless of direction, regardless of effort, in every possible direction at once. There is no direction you could travel that brings you closer to it. There is no version of catching up. That's a difficult kind of boundary to picture honestly, because every boundary we're used to in ordinary life can, at least theoretically, be approached, touched, crossed. This one only ever recedes evenly from everyone, everywhere, all the time, a boundary that behaves less like a wall and more like a tide that never comes back in. That's a genuinely uncomfortable thought. If you let it sit for more than a moment, that isolation on a cosmic scale isn't something being done to anyone, isn't a punishment or an accident, but simply the ordinary long-term consequence of how expansion behaves once you give it enough time to work. Nobody arranged it. Nobody could prevent it. It is simply what an expanding, accelerating universe eventually does to the relationships between the things inside it, whether or not anything inside it minds. Some researchers have tried to imagine what the sky will look like, far enough into the future for whoever or whatever might still be capable of looking up. The picture isn't apocalyptic exactly. It's quieter than that, and in some ways stranger. Trillions of years from now, most of the galaxies we currently catalogue, photograph and name will have receded past that horizon entirely, their light having long since redshifted into wavelengths no plausible instrument could catch. The sky, from the vantage point of whatever remains gravitationally bound to our own galaxy, would eventually look mostly empty, dark, and still, populated by a shrinking handful of nearby companions and not much else, the greater universe having simply drifted permanently out of view. A future observer in that far-off era, looking up, might reasonably conclude that the universe consists of only what they can see, a single galaxy or a small huddle of them, floating in an otherwise empty dark. They would have no direct way of knowing that an entire universe, full of galaxies beyond counting, once sat visibly within reach of an earlier version of the sky, before the light carrying news of it stopped arriving. The evidence would simply be gone, not destroyed, not hidden, just permanently, irrevocably out of reach, the way a book can still exist somewhere while being permanently unreachable to someone who will never again be handed a copy. It's a strange kind of forgetting, if forgetting is even the right word, since nothing is erased anywhere. The information doesn't vanish from existence. It simply becomes unavailable to any observer sitting where we happen to be sitting forever. A permanent kind of not knowing built directly into the geometry of an expanding universe, rather than into any particular failure of memory or instrumentation. I don't know what to do with a fact like that except turn it over slowly and let it sit uncomfortably for a while, the way you might sit with news that changes how you understand something you assumed was simply, permanently, given. The sky as it exists tonight is, in some very real sense, more complete, more populated, more full of visible neighbours than the sky any sufficiently distant future observer will ever be shown. We are, without having done anything in particular to deserve it, standing at a comparatively rich moment in the history of what can be seen at all, a moment that will not last, and that nobody currently alive will be present to watch end. I find myself circling back to the house image because nothing more efficient has ever replaced it in my own head. Some windows are lit by light from places already gone. Some houses exist, fully, and simply haven't been lit yet, waiting their turn in a line that may take longer than civilizations tend to last. And some houses are lit right now, for what may be one of the last times, their light already stretching thin as the space around them pulls away faster than anything can catch. None of these three conditions look any different from one another on an ordinary clear night. You can't tell, just by glancing up, which lit windows belong to houses still standing, which belong to houses long gone, and which belong to houses about to slip past a horizon they don't know exists. The sky doesn't sort them into categories for you. It just presents all three, indistinguishable, side by side, and lets you assume you're looking at one single, coherent present moment, when you're actually looking at three entirely different kinds of expired, pending, and vanishing information, layered on top of each other without a seam. There's a strange kind of loneliness in that last category, if loneliness is even the right word for it at all, since nobody involved anywhere is capable of feeling anything about it one way or another. A galaxy sliding past the cosmic horizon isn't being punished, or hidden, or erased. It's simply, gradually, becoming permanently unreachable, its last few photons straggling in decades or centuries from now, weaker each time, until eventually nothing more arrives at all, and it passes quietly out of anyone's observable universe forever, still existing, presumably, wherever it actually is, just no longer available to be seen by anyone on this side of the horizon. Whoever might be living somewhere within that galaxy, if anyone is, would notice nothing unusual happening to them locally. From their side, everything continues exactly as it always has. It is only from far away, from a place like this one, that they begin fading out of relevance, one incrementally weaker photon at a time, until the fading becomes absence, and the absence becomes, eventually, as if they had never sent anything toward us in the first place. I don't think there's a tidy way to end a thought like that, and I'm not going to try to force one. The house metaphor gets you partway there and then quietly runs out of road, the way most metaphors do eventually when you push on them long enough, past the point they were ever really built to hold. What's left underneath the metaphor, once it's finished running out, is simply this. The sky above you tonight is not one guest list. It's several, overlapping, none of them labelled, each window telling you something true about a different moment that has already happened, is still happening, or is in the process of becoming permanently unreachable, and there is no way to tell just by looking which is which. A clock that hasn't started. Inside, right now, it is dark and getting warmer, slowly, in a way that has no particular hurry to it. Not fire, not yet. Just pressure, building, slow, patient, the way a held breath builds before anyone decides to let it go. I am somewhere near the centre of a cloud that used to be nothing much. Cold gas, loose dust, drifting apart more than it ever drifted together, content in its own indifferent way to stay loose forever. Something changed that. A passing shock wave, maybe, from some other star finishing its own life somewhere nearby, or simple gravity finally winning an argument it had been quietly losing for a long time. Whatever it was, the cloud started folding in on itself, and it hasn't stopped since. Here is the part that surprises people. This isn't a star yet. Not by the only definition that actually matters, the one astronomers actually agree on, rather than the loose way the word gets used everywhere else. A star, properly defined, is a place where hydrogen fuses into helium, releasing the light and heat we recognize from every star we've ever named. This isn't that. Not yet. This is something else. Something with its own name, quieter and less famous. A protostar. A clock that hasn't started. The collapse itself makes heat, on its own, without any fusion at all. As the cloud falls inward, gravitational energy gets converted directly into warmth. The same basic principle that heats your hands when you rub them together, just scaled up to something the size of a solar system. The core tightens further. The pressure climbs a little more. The temperature follows, slowly, stubbornly, over tens of thousands of years, sometimes longer. I sit inside that slowness, and it does something strange to time. Out here, near the centre, nothing about the wait feels urgent. It isn't. There's no deadline. There's only pressure, accumulating, the material above pressing down harder as more of the cloud finishes its fall, and the core beneath it responding the only way matter under that kind of weight can respond, by getting hotter. At some point the whole cloud swells outward again, briefly, material bouncing back from the inrush, a kind of exhale after the long-held breath. Then it falls back in, harder this time, tighter, and the temperature climbs another notch it will never give back. 10 million degrees. That's the number this whole process is quietly working toward. The one specific temperature at which hydrogen nuclei finally start overcoming their own resistance to being forced together, fusing, releasing the first true stellar light this place will ever produce. Below that number, nothing ignites. Above it, everything changes at once. It's worth sitting with how much has to happen just to reach that one number. The core isn't simply sitting there, waiting passively for heat to accumulate on its own schedule. It's being squeezed continuously by the weight of everything still falling toward it from further out in the cloud. Material that hasn't finished arriving yet, adding its own mass to the pile, tightening the grip a little more with every additional layer that completes its own long fall inward. The core doesn't get to rest between increments. Each new arrival presses harder than the last. Until that number is reached, the protostar glows anyway, dimly, from the contraction alone, radiating away some of the heat generated simply by falling inward on itself. It looks, from a distance, almost like a star already. It behaves like one, faintly. It simply hasn't crossed the one threshold that would make the label accurate. I keep waiting for something to feel different, and for a long time nothing does. The core tightens, the heat climbs, then it plateaus briefly, some balance holding for a while between the pressure pushing out and the weight pressing in, before the balance breaks again and the temperature resumes its slow climb. This is the part I don't think I ever fully explain right. Nothing outside this cloud knows what's about to happen. No signal goes out ahead of the ignition. No warning light. The star that will eventually shine here gives no advance notice to whatever must be watching from somewhere else in the galaxy. It simply isn't shining yet. And then, one day, measured in tens or hundreds of thousands of years of build-up, it is. The ignition itself, when it finally comes, isn't gradual. It's closer to a threshold being crossed than a dial being turned. The core reaches the necessary temperature, hydrogen fusion begins in earnest, and the outward pressure from that new energy finally matches, then balances, the inward pull of gravity that had been winning this whole time. The collapse stops, not because gravity gave up, because something finally pushed back hard enough to hold the line. That's the strangest symmetry sitting at the center of this entire story. Tens of millions of years of slow, patient, almost imperceptible build-up, and then, at the very end of it, a genuine turning point that arrives in what amounts to no time at all, by comparison. The long wait doesn't taper off gently into the ignition. It simply stops being a wait all at once, the moment the one necessary condition is finally satisfied. That balance has a name too, one that undersells how precarious it actually is: hydrostatic equilibrium. A star, once it exists properly, spends the rest of its life sitting inside that balance, fusion pushing out, gravity pulling in, neither one ever fully winning, for as long as there's fuel left to keep the argument going. It's strange to think that the entire visible life of a star, everything it will ever do, all the light it will ever cast across however many worlds happen to be watching, depends entirely on that one balance holding steady, day after day, for billions of years, without anyone tending it, without anything keeping score. The star doesn't monitor itself. It simply sits inside a set of physical conditions that happen to hold, for now, until eventually, much later, they won't. I think about the moment just before that balance locks in, more than almost any other moment in this whole process. Everything that came before it, the folding cloud, the slow heat, the long patient centuries of contraction, was building toward a single specific instant, and until that instant arrives, none of it counts yet officially as a star. It's close. It's almost there. It has been almost there for longer than anyone watching from outside could easily imagine. For a star roughly the size of our own sun, this whole build-up, from loose cold cloud to properly ignited star, takes somewhere in the range of tens of millions of years, depending on how much material was available and how quickly it happened to gather. That's a genuinely difficult span to hold in your head, honestly. Entire mountain ranges rise and erode in less time than this one process takes to finish. Whole species can appear, spread, and vanish before a single protostar finishes deciding whether it's ready. somewhere else entirely in the galaxy, right now, another separate cloud is doing exactly this, at an earlier stage, its own clock even further still from starting, and somewhere else again, still, one has just crossed the threshold, this one is still approaching, its first true light only just now beginning the long, outward journey toward whichever distant eye might eventually receive it. None of these clocks start on the same schedule. Some clouds fold quickly, pulled in by nearby mass, and ignite within a comparatively short span. Others may drift for far longer instead, held apart by their own thin density, taking their time in a way that has nothing to do with patience and everything to do with how much material was there to begin with and how tightly it happened to be packed. I don't know, from inside this particular collapse, how much longer the wait will be. That's not false modesty. Nobody inside a process like this one gets an early copy of the answer, not the cloud itself, not whatever instruments might eventually be pointed at it from somewhere far away. The temperature climbs, the pressure builds, the balance keeps almost arriving and then slipping just short of arriving, and the only honest thing to say about any of it is that it hasn't happened yet and it will, and there is no way to rush the part in between. The space between the sending and the seeing. Something has already collapsed, somewhere out past anything you could easily name or point to. Somewhere, a core the size of a small planet has just finished falling in on itself, in less time than it takes to read this sentence, and the star wrapped around it hasn't found out yet. That's the strangest part of this whole story, and it's the part almost nobody ever hears about, because it doesn't involve anything you can actually see with your own eyes. It involves something you can't see at all, something that passes through you, right now, in staggering numbers, every second, without you ever noticing, without a single one of them ever announcing itself. I'm encountering this for the first time the way it actually happened, in order, and it still doesn't sit easily, even laid out plainly like this. A star large enough, at the very end of its life, runs out of the one thing keeping it stable. Fuel it can still fuse. The core, no longer held up by the outward push of ongoing fusion, gives way, all at once, collapsing inward in a fraction of a second, crushing itself down into something impossibly dense. In that instant, an almost incomprehensible number of particles get produced, particles so slippery, so profoundly uninterested in interacting with ordinary matter that the vast majority of them pass straight through the entire remaining bulk of the star as if it simply weren't there. These are neutrinos, nearly weightless, chargeless, moving close to the speed of light, and so reluctant to collide with anything that a wall of lead, a light year thick, would still let most of them straight through. The star's own collapsing core, dense as it briefly becomes, barely slows them down at all. They leave almost instantly. Within seconds of the collapse, the neutrinos are already free, already racing outward, already carrying the actual news of what just happened. Light does not get the same deal at all, not even close, no matter how fast it's supposed to be. This is the part that surprised me the most, the first time I actually sat with it. You'd think light, being light, would be the fast one, the first messenger out the door. It isn't. Light is made of photons, and photons interact constantly with the matter around them, absorbed and re-emitted over and over, bouncing through the dense material of the star's outer layers, like something feeling its way through a packed, unlit room, one collision at a time, in no particular hurry, in no particular direction. That process has an actual name, one that undersells how strange it is: photon diffusion. Light doesn't travel in a straight line out of a star's interior. It staggers, it wanders. Each photon might travel a tiny distance before slamming into a particle, absorbed, and re-emitted a moment later, heading in some new unrelated direction, only to repeat the whole process almost immediately. Multiply that stagger by the sheer density of a stellar interior, and the light that would cross the same distance in a straight line in seconds can instead take thousands of years, sometimes tens of thousands, just to find its way out. It helps, a little, to picture what that journey actually looks like, moment to moment, even though nobody has ever watched it happen directly. A single photon, born somewhere deep in a stellar core, sets off toward the surface, only to be swallowed almost immediately by a nearby particle. It disappears briefly as light and reappears an instant later, reborn, heading in some entirely new direction, one that has nothing to do with where it was originally going. This happens again and again, millions of times, billions of times. Each individual step is almost meaningless, a tiny stumble in a random direction, and yet the sheer number of these stumbles piled on top of each other for years on end is what eventually gets a photon to the surface at all. If you tried to time a single photon's actual straight-line distance from the core to the surface of a star like our Sun, the number would be almost embarrassingly small. A distance light could cross in about 2 seconds if nothing stood in its way. Instead, estimates for how long it actually takes a photon to randomly stagger its way out of a star's dense interior run into the tens of thousands of years, sometimes longer, depending on the exact conditions inside. The photon isn't slow. Light is never slow. It's simply interrupted constantly over and over for as long as it takes to finally stumble into open space. So here is the situation, laid bare. The actual event, the collapse itself, releases 2 messengers at essentially the same instant. One of them, the neutrinos, walks straight out the front door, unbothered, uninterrupted, gone in seconds. The other, the light, is stuck inside, bouncing off every wall, in the building for years, sometimes millennia, before it finally stumbles its way to an exit. I keep circling back to that image, the 2 messengers, born together, departing the same instant, and yet arriving at wildly different times, not because of anything to do with the distance they'll eventually cross through space, but because of what happens to each of them before that distance even begins. Once the light does escape, of course, it faces the ordinary crossing everyone already expects. However many years or millennia the actual span of space between the star and an observer happens to be, that part is familiar. That part is simply the corridor. But before the corridor even starts, some messengers already had a head start measured in years or centuries that had nothing to do with distance and everything to do with what kind of messenger they happened to be. Neutrinos skip the maze entirely without a second thought. Photons live inside it, for as long as it takes. There's a listening quality to all of this that I don't think gets discussed enough. The sense that detecting a neutrino burst is less like seeing something and more like hearing it. A signal arriving through instruments built specifically to catch something that leaves almost no other trace. The detectors built to catch neutrinos sit buried deep underground, or submerged in enormous tanks of purified water, waiting, listening for the extraordinarily rare occasion when one of these nearly massless particles actually does interact with something, producing a faint, fleeting flash that a sensitive enough eye, watching in total darkness, might just catch. In February of 1987, that listening paid off. A supernova erupted in a nearby satellite galaxy, close enough, astronomically speaking, to actually study in real detail, the first one bright enough for modern instruments in nearly 4 centuries. And in the hours before anyone on Earth saw so much as a flicker of new light in the sky, 3 separate neutrino detectors on different continents, entirely unaware of each other in the moment, each registered a distinct short burst of neutrino events, clustered together in time, arriving within about a 13-second window. The detectors themselves weren't built with a supernova in mind, not originally. They'd been constructed for an entirely different purpose, mostly to search for a far rarer and stranger phenomenon involving the possible decay of protons, and neutrino detection was, for most of these instruments, a kind of unavoidable background noise they simply had to learn to filter, or occasionally to notice. Enormous tanks of ultra-pure water, watched over by rings of sensitive light detectors, sat waiting patiently for the extraordinarily rare flash produced when a neutrino, against all odds, actually did interact with a particle inside the tank. Most of the time, nothing happened. On this particular night, in 3 different locations, something did. Nobody knew in that moment what they'd just caught. The burst came and went in seconds. It took hours of comparing notes afterward for anyone to realize that 3 separate instruments on 3 separate continents had all just quietly recorded the same event, the actual moment of core collapse, hours before the star's visible brightening ever reached telescopes. What makes this particular case so unusual, so worth returning to again and again, is that it's the only time in recorded history anyone has managed to catch both messengers from the same stellar collapse, close enough together, clearly enough to actually compare their arrival times directly. Every other supernova ever studied has come to us only as light, its neutrino burst, if one even occurred, having passed through undetected, too faint, too far, too poorly timed against whatever instruments happened to be listening at the moment. This one event from this one star in this one galaxy gave astronomers something they'd never had before and so far have never had since, a direct measurement of the actual gap between the 2 kinds of news leaving the same collapsing core. Roughly 3 hours passed between that neutrino burst and the first detection of the supernova's rising visible light. 3 hours for an event whose 2 messengers left the collapsing core at essentially the same instant. That gap, small as it sounds against the century-long story of the light's escape from a star, was the direct, measured signature of exactly the difference this chapter has been circling. One messenger walking straight out, the other stuck wandering the halls. I find something almost tender in that 3-hour gap, small as it is. It's a number you can actually hold, actually picture, unlike the more abstract deep-time descriptions of stars and collapse that tend to blur together after a while. 3 hours is an afternoon. It's the length of a long meal, a flight, a nap that runs too long. And somewhere in that ordinary, human-sized stretch of time, one kind of messenger had already told the truth, quietly, to instruments listening in the dark, while the rest of the universe waited for the second messenger to catch up. The neutrinos themselves, once detected, told scientists something the light alone never could have: the precise instant of collapse, unclouded by the long diffusion delay the light had to suffer through. For that one supernova, the neutrino burst effectively handed astronomers a clean, direct timestamp on an event that would otherwise have been smeared, blurred, buried inside centuries of photon wandering. They could never fully unwind after the fact. There's something worth sitting with in how differently these two messengers behave, given that they were born from the exact same instant of collapse. The neutrino carries the truth plainly, immediately, almost carelessly, indifferent to whatever stands in its way. The photon carries the same truth, eventually, but only after being interrupted so many times that by the time it finally emerges, its journey through the star alone has taken longer than entire empires have lasted. Both are telling the truth. Neither is lying. They simply arrive on entirely different schedules, shaped not by the distance ahead of them, but by what happened to each of them in the very first moments after they were made. It's strange to think that the most honest messenger, out of the two, was also the hardest one to catch. Trillions of neutrinos from that same explosion passed through the Earth, through every person standing on it, through this very sentence's author, and only a small handful, caught by pure chance inside a few carefully built detectors, ever actually registered at all. Nearly all of the truth simply passed straight through, unnoticed, the way it always does, the way it's doing again right now, from other stars, other collapses, other events nobody has caught yet. That's the part that stays with me longest, longer than the collapse, longer even than the 3-hour gap. Most of what's true, in this particular sense, isn't hidden. It isn't secret. It's simply passing through, constantly, at every moment, mostly unfelt, mostly unregistered, waiting for the rare, specific circumstance in which something built specifically to notice happens to be standing in exactly the right place, at exactly the right instant, ready to catch it. Consider what that means at any given moment, right now, while you're reading this. Neutrinos from ordinary stellar processes, from the Sun, from distant collapses nobody has yet identified, are passing through your body in numbers too large to comfortably picture, entirely unfelt, entirely undetected by anything you carry inside you. Roughly 100 trillion solar neutrinos alone pass through an ordinary human body every single second, entering through one side and exiting through the other without so much as a single collision along the way, most nights, every night, whether you're asleep, awake, or thinking about anything else entirely. You are, at this very second, a kind of quiet witness to events you'll never consciously register, a detector built for entirely different purposes, letting nearly everything slip straight through. There's an odd kind of comfort buried somewhere in that fact, if comfort is even the right word for something this indifferent. You are, whether you ask for the role or not, constantly receiving genuine information about the interior of a star 93 million miles away, in real time, correctly, honestly, and you will never know it, not directly, not through any sense you are built with. The information arrives. It simply arrives in a form your body has no way of noticing, the way a letter written in a language you've never learned might still technically reach your mailbox, still technically say something true, without ever managing to say anything to you. The light, meanwhile, is still doing what light does, wandering, bouncing, taking its slow, indirect 1,000-year route out of whatever star it happens to be inside of right now, patiently working its way toward an exit it hasn't found yet. There is no shortcut it can take. There is no version of this where enough patience or enough curiosity from the outside speeds along a single photon's stagger through a stellar interior even slightly. This stumbling simply continues at its own pace for as long as it takes. Think for a moment about how many different stages this single process is quietly occupying, all at once, scattered across the galaxy at any given instant. Somewhere, a core has just collapsed, its neutrinos already gone, already free, already speeding outward toward whatever happens to be in their path. Somewhere else, an older collapse from centuries ago is only now producing its first sliver of visible light at the surface of its star, the photon having finally, after all this time, found its way out of the maze. And somewhere else, again, deep inside some other still stable star, an entirely unrelated photon is only a few years into what will be a journey lasting tens of thousands more, still stumbling, still colliding, still nowhere near ready to leave. None of these stages announce themselves to each other. None of them know they're part of the same broader pattern, repeating itself quietly in star after star, all across the galaxy, all at once, forever. The pattern is only visible from far enough outside it, looking down at the whole shape of the thing rather than at any single messenger caught inside it. There's one more layer to this worth sitting with before it's finished, one that circles back to where the whole thing started. The star itself, the visible outer layers of it, the part any observer would actually recognize as a star, doesn't know its core has collapsed. Not yet. For as long as it takes the shock of that collapse to physically work its way outward through the star's remaining bulk, the outer layers simply continue doing what they've always done, shining steadily, unaware that the foundation beneath them has already given way. The star, in a very real sense, is still living in the moment before its own death, even after that death has already technically occurred. That delay, the one between the core's actual collapse and the outer layers finally receiving news of it, isn't measured in years the way the light's diffusion time is. It happens far faster, over hours, as a genuine physical shockwave ploughs outward through the star's remaining material, eventually reaching the surface and producing the sudden, catastrophic brightening that observers eventually recognize correctly as a supernova. But even that shorter delay is still a delay, still a gap between the sending and the seeing, still a version of the same fundamental pattern, playing out on a smaller, faster scale, nested inside the much larger one this whole chapter has been following. Nothing about this process moves instantly at any scale, from the sub-second collapse of the core to the millennia-long stagger of a single photon finding its way out. Every layer of it involves something happening first, somewhere, and something else finding out about it later, at whatever pace that particular kind of news happens to travel. There is no version of a stellar death that announces itself everywhere, all at once, evenly, the instant it occurs. There is only ever the sending, and then, later, sometimes much later, the seeing. Somewhere, a star's core is already gone, its collapse complete, its outer layers still shining on in blissful temporary ignorance of what's already happened beneath them. Somewhere else, the light that will eventually announce a much older collapse is still years or centuries from finding its way out of the wreckage above it, still stumbling, still colliding, patient in the only way matter can be patient. And somewhere else again, a neutrino that left some other collapsed core. Sometime in the last few seconds has already crossed most of an entire galaxy, indifferent, unbothered, entirely unaware that it's carrying the only honest account of something the rest of the universe hasn't heard yet and won't for a very long time still. What the sky is still deciding. Look up right now at whatever's overhead, wherever you happen to be standing, and you're already in the middle of something, not the beginning of it. The light arriving at this exact instant has been arriving the whole time you've been alive, the whole time anyone has ever been alive. Continuous, uninterrupted stream that never once paused to let you catch up. You didn't walk in at the start of any of this. Nobody ever does. There isn't a start left anywhere to walk in at. I'm standing next to you for this one. Not ahead of you, not behind you, just beside you, looking at the same patch of sky, trying to actually take in what's genuinely happening in it, rather than simply naming the pieces and moving on quickly. Start wide as the whole sky lets you. The whole visible sky, taken in at once, looks like a single surface, evenly lit, a scattering of points arranged against the dark the way an ordinary photograph arranges everything it captures into one flat, simultaneous instant. That's the illusion, and it's a genuinely convincing one, because nothing about the sky visually announces which of its many points belong to which era. It all just sits there together, equally present, equally now, as far as any casual glance could ever tell. It isn't equally anything at all. Consider the planets first, since they're the closest thing up there to actually being current, at least by the standards of anything else this chapter is about to describe. A bright point like Jupiter is showing you sunlight reflected off its clouds that left the sun 8 minutes ago, bounced off the planet, and took another 40-some minutes, depending on where Earth and Jupiter happen to be in their orbits, to reach your eye. Less than an hour old, all told, almost fresh by the standards of anything else in the sky tonight. Move to an ordinary star, one without a name most people would recognize, and the light gets older, sometimes by a little, sometimes by a lot, depending entirely on how far away that particular point of light happens to be. Some of the stars visible on any given night sent their light out only a few years ago. Others, and there's no way to tell which just by looking, sent theirs out centuries ago, sometimes far longer, arriving now only because now is when the crossing happened to finish. That's not hypothetical. Some fraction of those stars quietly, without any visible change in how they currently appear, no longer exist at all. A star can burn through its final reserves, collapse or otherwise end, and the light already dispatched before that ending simply keeps arriving on schedule for as long as the distance demands, entirely unaware that the thing producing it has already finished. You cannot tell by looking which of tonight's steady, ordinary-looking stars belong to this category. Nothing about their light announces the difference. It simply arrives, indistinguishable from light sent by something still perfectly intact. And then, if the sky is dark enough and your eyes are patient enough, there's a smudge, easy to miss. That isn't a star at all. It's an entire galaxy, over 1 trillion stars, and the light reaching you from it left over 2 million years ago, before anything resembling a modern human had ever stood anywhere on Earth looking up at anything. That light has been travelling, uninterrupted this entire time, arriving now, tonight, landing in the same glance you're giving to a planet whose light is less than an hour old. That particular smudge has a name, though the name matters less than the fact that you can see it at all, unaided, with nothing but your own eyes, on a sufficiently dark and clear night. It sits roughly 2.5 million light-years away, which makes it, without much competition, the most distant single object the ordinary human eye can register directly, without a telescope, without any instrument standing between you and the light itself. Everything else visible to the naked eye belongs to our own galaxy. This one doesn't. This one is a genuine outsider, a separate island of stars entirely, its ancient light having crossed a gap so large that the number describing it barely means anything intuitively, and yet there it sits, faint, steady, entirely unremarkable to a casual glance, easy to walk past without noticing. Nothing in the actual appearance of the sky separates these ages from each other. They don't fade differently based on how old they are. They don't carry some visible timestamp. An hour-old point of light and a 2-million-year-old smudge sit in the same field of view at the same apparent brightness range, asking to be read as if they were reporting from the same moment when they're doing nothing of the kind. I think this is the part that's genuinely hard to hold on to, harder than any single fact buried inside it. The sky isn't a photograph. A photograph captures one instant, everywhere in the frame, simultaneously all its subjects agreeing implicitly to share the same fraction of a second. The sky captures nothing simultaneously. It's closer to a very long exposure, one that's been running continuously since roughly 13.8 billion years ago, still running, never once finished, layering arrival after arrival into what only looks, from where you're standing, like a single completed image. Zoom in further, not to the size of a planet or even a star, but to the size of a single point of light landing on the back of your eye. A photon, having crossed whatever distance it needed to cross, whether an hour's worth or 2 million years' worth, finally strikes a single light-sensitive cell in your retina, one specific molecule inside that cell absorbing the photon's energy and triggering, through a short chain of chemical reactions, the tiny electrical signal your brain will eventually interpret as a point of light. That final step, the one happening inside your own eye, takes almost no time at all, a fraction of a second compared to everything that came before it. A single molecule inside that light-sensitive cell, one shaped specifically to catch a photon and change shape slightly upon absorbing it, does its work in a span of time so brief it barely qualifies as a duration at all. And that tiny structural shift is enough to set off the chain of chemical signals that eventually reaches your brain as something you'd simply describe as seeing a star. Everything before that instant took years, or centuries, or millions of years. The instant itself takes almost nothing, and yet it's the only part of this entire chain that actually completes anything. Everything else, all those years or millennia of travel, all that distance, all that time, was simply the build-up to one photon finally finding one cell, in one eye, at one particular moment that could have gone differently, could have missed entirely, could have landed a fraction of an inch to either side and struck nothing at all. There's something worth sitting with in how much had to go right, cosmically speaking, for that one photon to end its multi-thousand-year journey inside your retina specifically, rather than in the empty space just beside your head, or in someone else's eye entirely or nowhere at all. Most of the light any given star ever produces never lands anywhere in particular. It simply radiates outward in every direction, forever, and only an infinitesimal fraction of it happens to be aimed, by pure geometric chance, at wherever an eye eventually turns out to be waiting. You are, in that sense, an accidental terminus for an enormous number of extremely long journeys, each one finishing at a slightly different point in its own private timeline, all of them converging coincidentally on this one evening, this one glance, this one collection of retinal cells doing their small, fast, final job. The sky, then, isn't finished. It never has been. It's still being written, one photon's arrival at a time, each new arrival adding one more line to a document that has no ending in sight, no final draft, no moment at which it could be called complete. What you're looking at, whenever you look up, is not the sky as it is. It's the sky as it has been arriving continuously, in overlapping layers of different ages, none of them synchronized, none of them waiting for the others to catch up. There's no editor sitting somewhere, deciding which arrivals get included in tonight's version and which get held back for later. The document simply accumulates, indiscriminately, every photon that happens to complete its journey counted, every one that doesn't simply absent without explanation, without apology. You are handed whatever happens to have finished arriving by the time you happen to look up. Nothing more curated than that, nothing more deliberate than pure coincidence of timing. I keep trying to find a cleaner way to say this and keep failing, mostly because the sky itself doesn't offer a cleaner version. It simply keeps doing what it's always done, delivering unevenly from every direction, at every possible age, an ongoing, unfinished account of a universe that has never once paused long enough to let anyone read it all at the same time. It's a strange kind of document to be handed, one written by no single author, compiled from no single moment, arriving in fragments that only look coherent because your eye happens to receive them all at once, regardless of how differently, how unevenly they were actually produced. The coherence is yours, not the sky's. The sky never promised you a single story, it only ever promised whatever happened to finish arriving. You're reading an early page of it tonight, incomplete, still being written somewhere out past everything you can currently see, and there is no version of catching up to the ending, because there isn't one yet. There may never be one, not in any sense that would let a reader, however patient, however long-lived, ever reach a final line and call the whole thing finished. The document simply continues, page after page, arrival after arrival, for as long as there is a universe left producing light, and a sky left willing to carry it the rest of the way, to whoever happens to be standing underneath, looking up on any given ordinary night. Losing the thread, I want to tell you exactly how far away that star is, and I want to be honest with you about something first. I'm not entirely sure I can hold the whole explanation in my head at once, and I don't think that's a failure on my part specifically. I think it might just be what this particular idea does to anyone who tries to hold it whole, however carefully trained, however many years they've spent working directly with exactly this chain of methods. Here's where it starts, plainly enough. You can't just look at something impossibly far away and read its distance off directly, the way you might glance at a road sign. Distance, out past a certain reasonable point, has to be built, piece by careful piece, using a chain of separate methods, each one reaching a little further than the last, each one depending entirely on the method before it having gotten things right. There's no way around this. It isn't a limitation anyone chose or a shortcut anyone was too lazy to avoid. It's simply a consequence of how measurement itself works once the thing being measured is too far away for any single, direct technique to reach on its own. Every method has a range past which it stops being reliable, and every one of those ranges, without exception, ends well short of the distances we now casually quote for the most remote galaxies. Something has to bridge each of those gaps, and the only honest way to bridge them is to build a sequence, one link handing off to the next, trust accumulating the same way debt or credit does, quietly, one transaction at a time. The first rung is almost embarrassingly simple once you see it. Hold your finger up, close one eye, then the other, and watch your finger appear to shift against the background. Now imagine doing that same simple trick, except instead of your two eyes, you use the two most distant points Earth ever reaches in its orbit around the Sun, 6 months apart, and instead of a finger, a nearby star. The star appears to shift, ever so slightly, against the more distant backdrop behind it, and that tiny shift, called parallax, combined with the known width of Earth's orbit, gives you an actual, direct, genuinely trustworthy distance. No strings attached, no assumptions, no borrowed reasoning at all. Just plain geometry, doing what geometry does, the same geometry a surveyor might use to triangulate the distance to a mountain, just scaled up until the baseline itself is the width of an entire planetary orbit. It's worth pausing briefly on how satisfying this first rung actually is, compared to everything built on top of it, precisely because it asks so little of anyone trusting it. It requires no assumptions about the physical nature of stars, no faith in any pattern discovered elsewhere, nothing beyond basic geometry, and a sufficiently precise instrument for measuring an extremely small angle. This is the one rung in the entire chain that anyone, given the right equipment and enough patience, could in principle verify personally from first principles without trusting anyone else's prior work at all. That method works beautifully, and then it stops working because the shift gets too small to measure reliably once a star is far enough away. Even with modern instruments capable of detecting shifts smaller than anyone could have managed a century ago, there's still a ceiling, a distance past which the apparent wobble of a star against its background becomes too faint to trust. The thread, at that point, has to be handed off to something else. The something else involves a particular kind of star that doesn't just shine, it pulses, brightening and dimming on a regular cycle, and the length of that cycle turns out to be tied, reliably, to how intrinsically bright the star actually is. This connection was noticed, originally, almost by accident, by someone cataloguing thousands of these pulsing stars in a distant satellite galaxy, and simply noticing that the ones with longer cycles were consistently brighter than the ones with shorter cycles, a pattern that had no obvious explanation until the underlying physics of the pulsation mechanism itself was eventually worked out, decades later, by other researchers building on that original careful observation. Find one of these stars, time its pulse, and you can work out its true brightness without ever needing to know its distance first. Compare that true brightness to how dim it actually looks from here, and the difference tells you, mathematically, how far the light had to travel to get so faint. This is the second rung, and it depends entirely on the first one having been built correctly, because the only way anyone ever trusted this method in the first place was by testing it on pulsing stars close enough for parallax to double-check the answer. I keep needing to stop here and remind myself what's actually happening in this chain, because it's easy to lose the sequence, and losing the sequence is sort of the point of this whole chapter, not a failure of it. The next rung reaches further still, using entire exploding stars, a particular kind of stellar detonation that occurs, reliably, when a dead star of a very specific mass finally collapses under its own weight, producing an explosion whose peak brightness follows its own predictable pattern, one bright enough to be visible across distances so vast that individual pulsing stars can no longer be picked out at all, even with the most powerful instruments available. And this rung too only holds because it was calibrated against the rung before it, tested against galaxies close enough that both methods could be applied and compared side by side. The newer one trusted only once it agreed with the older one closely enough, across enough examples, to rule out coincidence entirely. There's a particular kind of vertigo that sets in around this point in the chain, one that has nothing to do with the mathematics, which is sound, and everything to do with simply trying to hold the whole structure in view at once. Each individual link, examined on its own, makes complete sense, is well tested, is defensible in isolation. It's the accumulation that becomes difficult, not any single step. You can understand the first rung completely, you can understand the second, on its own, just as completely, but holding both, plus the fourth, all simultaneously, each one leaning on the one beneath it, is a different kind of task entirely, one that seems to exceed what any single sitting of attention can comfortably manage. I've noticed this same difficulty surface in conversations with people who've spent entire careers on exactly this chain of measurement. People who could recite each individual method in precise technical detail without hesitation, and who still, when pressed to walk the whole sequence out loud from the very first rung to the very last without pausing, occasionally stumble, correct themselves, double back to check they haven't skipped a step. That isn't a mark against their expertise. It might be the clearest evidence yet that the difficulty here isn't a matter of missing knowledge. It's a matter of scale, the same way holding a single grain of sand is easy, and holding an entire beach, grain by grain, in your two hands simply isn't, regardless of how well you understand what sand is. By the time you reach the furthest rung, the one that measures the recession of entire distant galaxies, by how their light has stretched and reddened during its long crossing, you're no longer measuring anything directly at all. You're trusting an entire chain, link after link, each one built on the one before it, none of them independently checkable against something even more fundamental all the way down. The final measurement, the one quoted casually in documentaries and captions and offhand conversations, in numbers that sound impressively precise and definitive, rests on a foundation 4 or 5 separate methods deep, each layer invisible beneath the single number reported at the very top. That's the part that unsettles me a little, if I say it plainly. Every distance claimed for the most remote things we can currently observe rests on a sequence of trust, each step reasonable, each step checked against its neighbour, but none of it checkable, all at once, from one end to the other, by any single, direct method. It's a chain. Chains hold until they don't. And to be fair, this one has held remarkably well for a very long time, cross-checked in more ways than I can easily list here, refined over decades by people far more careful than casual doubt gives them credit for. Different independent techniques, developed separately by different researchers working in different countries, using entirely different physical principles, have converged on results close enough to each other that the overall structure has earned its trust honestly, not through blind faith, but through repeated, careful agreement. I'm not suggesting the chain is wrong. I'm suggesting something quieter, that the confidence we feel when we quote a distance in the trillions of miles is confidence borrowed several times over, passed hand to hand down a very long line, and somewhere in the middle of retelling that whole story, it's easy, even for someone who understands each individual link, to lose track of exactly where you are in the sequence. There's an ongoing disagreement, still unresolved as of this telling, between two different ways of measuring one of the numbers that sits near the top of this entire chain. A disagreement small in absolute terms, but persistent enough and consistent enough across repeated, careful measurement that it has occupied entire careers trying to explain, generating conference talks, competing papers, and a fair amount of good-natured professional stubbornness on both sides of the debate. Nobody yet knows for certain whether the discrepancy points to some subtle flaw buried deep in one of the chain's earlier rungs, or whether it's hinting at some genuinely new physics nobody has accounted for yet. Either possibility is faintly unsettling in its own way. That a structure this carefully built, tested this many times, cross-checked by this many independent teams, might still be quietly wrong somewhere in a place nobody has managed to locate. I think that's true of understanding in general, actually, not just this one chain of measurements. You start somewhere solid, something you can hold directly, parallax, a finger, a shift you can practically see with your own eyes, and you follow it, rung by rung, each step reasonable on its own, until at some point, without quite noticing when it happened, you're several rungs removed from anything you could verify yourself, trusting a structure you can no longer see the base of. That's not a flaw in you. It's not sloppy thinking, and it certainly isn't a failure of attention. It's simply what happens when an idea gets built tall enough. At some point, holding the whole structure at once, from the very first rung to the very last, stops being something any single mind does casually, and starts being something you take partly on trust, the way you might trust a bridge without personally checking every bolt, every weld, every calculation that went into its design decades before you ever set foot on it. Consider for a moment how strange it is that this entire towering structure of distance, spanning the difference between a nearby star and a galaxy, on the very edge of what any telescope can register, ultimately traces back to something as simple, as almost childish, as noticing your finger appear to shift when you close one eye and then the other. Nothing about that first observation hints at the scale of what eventually gets built on top of it, and yet every subsequent rung, however sophisticated, however dependent on physics unimaginable to whoever first measured a stellar parallax centuries ago, still owes its entire foundation to that same small, plain, almost forgettable trick, performed originally with nothing more elaborate than careful eyes and a great deal of patience. I lost my own place somewhere around the third rung writing this, and had to go back and retrace the sequence twice before continuing, checking which method depended on which calibration came first, which star provided the anchor for which technique, and which number, once agreed upon, quietly became the assumption everything afterward was built on top of without further question. That's not incidental to what this chapter is actually about, and I don't think it reflects poorly on the chain itself, or on anyone else who might lose their footing at the same point, however carefully they've studied it before. Some ideas simply aren't meant to be held whole, not by any single mind, not in a single sitting, not even by someone who has spent years living inside exactly this problem. They're meant to be entered, partially, dropped into at whatever rung happens to be nearest, and trusted the rest of the way up, the way you'd trust a ladder without needing to personally inspect every rung above the one your hand is currently gripping, the edge that isn't an edge. There is a boundary out past a certain kind of dying star somewhere in the galaxy, and I've been avoiding calling it what people usually call it, because the usual name suggests something it isn't, and I'd rather work up to the name honestly than start with a term that already carries the wrong picture. People call it an event horizon. The word horizon does a lot of quiet, misleading work in that phrase, because an ordinary horizon, the one you'd find at any beach, isn't a wall. It's simply the limit of what you happen to be able to see from where you're standing, a limit that moves if you move, that vanishes the moment you walk toward it. That was never really there in the object sense at all. You could, in principle, keep walking toward an ordinary horizon forever and never once touch it, because it was never a place to begin with, only ever a description of your own vantage point. This one behaves nothing like that. Here's what actually happens. A star, massive enough, at the end of its life, collapses so completely that its own gravity overwhelms every other force that might otherwise hold it up. The material doesn't just get dense, it gets denser than anything else known to exist, packed into a region small enough that the gravitational pull at its surface exceeds the speed of light itself, which is another way of saying that light, the fastest thing there is, the thing nothing else in the universe can outrun, cannot escape. Past a certain measurable distance from that collapsed core called the event horizon, nothing that crosses it can ever, under any circumstance, cross back. Not light, not anything, ever. This isn't a matter of insufficient technology or clever engineering someone simply hasn't thought of yet, some problem awaiting a sufficiently determined future engineer. It's a geometric fact about the region itself, built into the structure of space near an object that dense, the same way it's a geometric fact that you can't draw a triangle with 4 sides, no matter how carefully or cleverly you try. I want to sit with that phrase again. Nothing that crosses it can ever cross back. Not eventually. Not with enough thrust, enough cleverness, enough time, enough advanced propulsion nobody has invented yet. The boundary isn't guarded. There's no gate, no wall, no barrier in any material sense at all. Space itself on the far side of that line simply curves in such a way that every possible direction, including every direction that might look locally like away, actually leads further in. That's the part that took me the longest to actually absorb, not just recite. We're used to boundaries that keep things out, or keep things in, through some kind of resistance, a wall pushing back, a fence you'd have to climb, a door you'd have to force. This boundary does neither. It doesn't resist anything crossing it. Crossing it, from the outside, would feel, to whatever crossed it, like nothing at all. No bump, no wall, no sensation of resistance whatsoever, at least for a sufficiently large black hole. The horizon isn't a membrane, it's simply the last place a returning path still exists, the final coordinate from which back is still a meaningful direction to describe. Past that point, away stops being a direction you can choose. It's a little like discovering that every path in a maze, no matter which one you pick, eventually leads to the same room. Except the maze isn't a metaphor here, and the room isn't a metaphor either. It's the singularity, the theoretical point at the very centre where, according to general relativity, all the collapsed matter has been compressed into, a place the mathematics describes but can no longer meaningfully picture. I say, according to general relativity deliberately, because this is the part of the story where honesty requires a caveat. General relativity, the theory that predicts singularities, is exceptionally well tested everywhere we've been able to check it, but it's also known to break down, mathematically, at the singularity itself, producing predictions of infinite density that most physicists suspect are a sign of the theory reaching its limits rather than a literal description of what's actually there. Nobody currently has a complete theory that correctly describes what happens at those extreme scales. The honest answer, at the very centre, is that we don't fully know. There's a strange detail buried in the size of these horizons that surprised me the first time I actually sat with the numbers. The size of a horizon scales directly and simply with the mass collapsed inside it. A black hole with the mass of our sun would have a horizon only a few kilometres across, small enough to fit comfortably inside a modest city. But the black hole at the centre of our own galaxy, the one whose surrounding stars have been tracked for decades, contains millions of times the sun's mass, and its horizon, correspondingly, stretches out to a size comparable to the orbit of Mercury. And some black holes, sitting at the centres of the largest galaxies known, contain billions of solar masses, horizons wide enough to swallow our entire solar system, orbit and all, without so much as brushing the edges. None of these horizons look the same, up close, in the way you might expect scale to matter. The physics governing them is identical regardless of size. A larger black hole isn't a more extreme version of a smaller one in any dramatic sense. If anything, the larger the horizon, the gentler the crossing would actually be for anything approaching it, a detail that runs against most people's intuition entirely. That gentleness has to do with something called tidal forces, the difference in gravitational pull between one end of an object and the other, a difference that becomes far more consequential the smaller and denser the source of gravity happens to be. Near a small black hole, that difference becomes extreme over a very short distance, stretching anything approaching it into an increasingly thin, elongated shape long before it ever reaches the horizon, a process physicists have, only half-jokingly, taken to calling spaghettification. Near a sufficiently large black hole, though, the horizon is so far from the crushing density at the centre that the difference in pull between your head and your feet, crossing that same horizon, might be negligible, small enough that you could, in principle, cross the boundary itself without feeling anything unusual at all, at least for a little while afterward. That's a genuinely strange thing to sit with, that crossing into a region from which nothing, not even light, can ever return, might, for a sufficiently large enough black hole, feel like absolutely nothing whatsoever at all, no dramatic transition, no obvious signal, nothing marking the moment your entire future became permanently sealed off from everyone you left behind. Time itself does something equally strange the closer you get to a horizon, something confirmed both by the mathematics itself and by direct experimental tests conducted much closer to home. using ordinary gravity here on Earth, far weaker than anything near a black hole, but strong enough to measure the effect precisely. Clocks placed at different heights, even a difference of a few feet, tick at very slightly different rates, the one closer to the ground running very slightly slower, an effect too small to notice in ordinary life, but large enough that sufficiently precise instruments have measured it directly, repeatedly, in careful laboratory experiments. Near a black hole, that same effect intensifies enormously. A clock lowered toward the horizon would appear, to a distant observer, to tick slower and slower the closer it got, approaching a complete stop as it neared the boundary, without ever quite seeming to finish crossing it, at least not from the distant observer's vantage point. From the perspective of whatever is actually falling, though, none of that apparent slowing would be felt at all. Its own clock would keep ticking normally, its own experience of time passing exactly as it always had, right up until the crossing itself, and beyond. This strangeness isn't something the falling object experiences directly. It's something built entirely into the relationship between the falling object and everyone watching from a safe distance. A genuine disagreement about time itself, with neither side technically wrong, both simply describing the same event from positions that experience it in fundamentally incompatible ways. I find that particular asymmetry more genuinely unsettling in some ways than the horizon itself. Two entirely honest observers, both applying the same well-tested physics correctly, would come away with completely different accounts of when, exactly, the crossing happened, one insisting it takes forever, approaching but never quite completing, the other experiencing it as an ordinary, unremarkable moment that came and went like any other. Neither account is a mistake. They're simply both true, from where each observer happens to be standing, in a way that ordinary intuitions about a single, shared, agreed-upon timeline were never built to accommodate. What we do know, with considerably more confidence, is the horizon itself, the boundary, not the centre. That part has been observed now, indirectly but unmistakably, multiple times. Stars orbiting an unseen companion at speeds that only make sense if that companion is both extremely massive and extremely small have been tracked for decades, their orbits mapped precisely enough to rule out any ordinary explanation. Astronomers spent many long years watching a small cluster of stars near the centre of our own galaxy trace out tight, fast elliptical paths around something entirely invisible, something with a mass equivalent to millions of suns crammed into a region no larger than our own solar system. No ordinary star, no cluster of ordinary stars, no known object besides a genuine black hole could ever fully explain orbits that fast, that tight, around something that completely dark. And more recently, an image exists, an actual image, not an illustration, not an artist impression, showing the glowing ring of superheated material swirling just outside a horizon, with a genuinely dark, roughly circular absence sitting at its centre, exactly where the horizon should be. That image took over a decade of careful preparation and a network of telescopes spanning the entire planet, synchronized precisely enough to functioning together, quite remarkably, as a single instrument roughly the size of Earth itself, because a black hole's horizon, even for one of the very largest known, is small enough from this immense distance that nothing else smaller could ever realistically hope to resolve it clearly. data from each individual telescope, recorded entirely independently at sites scattered from Antarctica to Hawaii to Spain, had to be combined carefully afterward with a precision measured in tiny fractions of a wavelength of light, a technical achievement that in some genuine ways rivals the astrophysical discovery it was originally built to confirm. I keep returning to that image because it's the closest anyone has come to actually seeing the edge itself, rather than simply inferring it mathematically. It doesn't show you anything happening at the horizon. It can't. It shows you the last light able to still make it out, orbiting just outside the boundary, before the boundary claims it, and a dark, empty circle exactly where theory said one should be. There's a further complication buried in all of this, one that has occupied physicists for decades and remains, even now, only partially resolved. It's worth remembering, too, that the idea of an object this extreme wasn't universally welcomed when it first emerged from the mathematics. The equations describing it were worked out remarkably quickly after general relativity itself was published. Within months, in fact, by a physicist calculating from the middle of an active battlefield, sending his results back through the mail while serving in the war. For decades afterward, many physicists, including the very people whose own equations predicted it, treated the possibility of a genuine horizon as a mathematical curiosity at best, a strange edge case unlikely to correspond to anything real, a flaw in the math waiting to be explained away rather than an actual object waiting to be found. It took decades more and considerably more evidence before the physics community came to accept that these objects weren't just theoretically permitted, but were in fact common, scattered by the millions throughout every galaxy, including our own, quietly anchoring the orbits of stars and in many cases entire galaxies around them. The resistance wasn't stubbornness for its own sake. It reflected a reasonable discomfort with a prediction this strange, one that seemed, for a long time, more like a symptom of incomplete physics than a genuine feature of reality. Reality in this particular case turned out to agree with the stranger reading. I think about that history sometimes when I think about the horizon itself, the fact that even the people who first wrote down its mathematics needed decades to fully believe what their own equations were telling them. There's something quietly reassuring in that, actually. A reminder that being skeptical of an idea this strange isn't foolishness. It's simply the ordinary, appropriate response to something that violates every intuition built from a lifetime spent nowhere near anything remotely this extreme. The universe, in this particular case, simply turned out to be stranger than the intuition built to navigate an ordinary life ever needed to prepare for. If nothing can escape a black hole, not even light, what happens to the information describing everything that ever fell in, every cup, every book, every star, every scrap of physical detail it once carried? One of the deepest assumptions running through essentially all of physics is that this kind of information is never actually destroyed, only ever rearranged, however thoroughly, however unrecognizably. A black hole's horizon appeared, for a long time, to violate that assumption outright, swallowing information completely, with no apparent way for it to ever be recovered by anyone, under any circumstance, at any point in the future. Then came a subtler prediction, one suggesting that a black hole isn't perfectly black after all, that it very slowly radiates a faint trickle of particles outward, over timescales so long they dwarf the current age of the universe many times over for anything of stellar mass, eventually evaporating away entirely, shrinking imperceptibly over unimaginable stretches of future time until nothing at all remains where it once sat. Whether that faint radiation actually carries the missing information back out with it, encoded somehow in a form nobody has yet figured out how to decode, remains one of the most actively debated questions in theoretical physics, argued over in papers and conferences and long, unresolved seminar disagreements by people who agree on almost none of the details, and yet remain convinced, collectively, that the answer matters enormously, that whatever the resolution turns out to be, it will say something fundamental about how information and gravity actually relate to each other at the deepest level physics has yet managed to probe. I find something almost comforting in that disagreement. Oddly enough, though comforting might be the wrong word for a debate this unresolved, this technical, this far removed from anything an ordinary evening spent looking up at the sky might prepare you for. It means the horizon still has something left to teach, that the story doesn't end simply because we've managed to photograph its outer edge. The visible boundary and the deeper mystery buried inside it are not the same achievement. One has been confirmed directly, decisively. The other is still genuinely up for grabs. There's something worth sitting with in the fact that the darkness in that image isn't the absence of anything happening. It's the opposite. It's the one place in the entire picture where the most extreme physics anywhere in the universe is actively occurring, continuously, and the only reason it looks empty is that none of what's happening there is able to send anything back out to tell us about it. That inversion feels important somehow, more important than it initially seems. We're used to darkness meaning absence, meaning nothing is there, meaning look elsewhere. Here, darkness means the opposite, not nothing, but everything, compressed and active and utterly sealed off, producing a silence that isn't peaceful so much as structurally enforced, the one place in the observable universe guaranteed never to explain itself to anyone standing outside it. It's worth considering, too, how differently this particular silence behaves compared to every other kind of silence discussed elsewhere in this whole series. The delay of ordinary starlight, the wait for a protostar's ignition, the years a photon spends stumbling through a stellar interior, all of those silences eventually end. The news eventually arrives. This one doesn't have that property. It isn't simply delayed. It isn't news that's still in transit, still crossing some vast but finite distance, still obeying the ordinary rules that govern every other kind of waiting. This whole exploration has touched on. Whatever happens past a horizon has, in the most literal sense available to physics, opted permanently out of the category of things that can ever become news to anyone on this side of the line. That's a genuinely different kind of not knowing than anything else in this entire story. Distant starlight that hasn't arrived yet is still, in principle, going to arrive eventually, given enough patience and enough time. A collapsing cloud's ignition, however, along the wait, is still eventually going to ignite, and its light will eventually reach some future observer somewhere. Even the neutrino and the slow, wandering photon inside a dying star's interior both eventually complete their crossing, however differently timed. The horizon offers no such promise. Its silence isn't a delay awaiting completion. It's a boundary condition, built directly into the geometry of the region, guaranteeing that certain events, once they occur past that line, will never, under any circumstance, become knowable to anyone standing safely outside it. I don't think there's a way to end a chapter about a boundary that doesn't resolve, that doesn't come to a point the way ordinary edges do. The event horizon isn't an edge in the sense of a place things stop. It's a place explanation stops, a threshold past which the ordinary relationship between an event and its eventual retelling simply ceases to apply. Whatever happens past that line happened. It's just never coming back out to be described. Not this year, not in a billion years, not ever, to anyone, under any circumstance physics currently understands. A door held shut by distance. There's a spacecraft out past the edge of the solar system's ordinary reach, further than anything else humanity has ever built has managed to travel. And if you wanted to send it a message right now, you would have to wait almost an entire day just to know whether it heard you. Not because anything is broken exactly. Not because the equipment is old, though it certainly is, older by now than most people currently reading this sentence. It's simply because the door between here and there is held firmly shut, not by any lock in the ordinary sense, but by distance itself. And distance past a certain considerable point behaves exactly like a stubborn lock that simply can't be picked, only patiently waited out. The spacecraft is called Voyager 1, launched in the late 1970s, and it is, at the time of this writing, the most distant human-made object that has ever existed, currently travelling through interstellar space, well beyond the outer edge of what's usually considered our solar system's boundary. It is over 24 billion kilometres away. A radio signal, travelling at the speed of light, the fastest anything can travel, takes roughly 23 hours to cross that distance, one way. Send it a command today, right now, this very moment, and you will not know, until tomorrow, whether it ever actually arrived. I want to sit with that plainly, without exaggerating it, because it doesn't need exaggeration. 23 hours is not an abstraction. It's an ordinary length of time, the length of a full day, the length of a long flight, the length of time you might go without checking your phone if you were trying for once to disconnect completely. And for that entire stretch, every single time anyone sends anything to that spacecraft, there is simply nothing to be done but wait, because nothing, not even light, can cross that distance any faster. This isn't a temporary limitation, waiting patiently on better engineering to eventually arrive. It isn't a bandwidth problem, or a bad connection, or anything at all that improves with a stronger signal or a bigger antenna. The delay itself is built entirely into the geometry of the situation, the plain fact of how far away the spacecraft currently is, and how fast information is permitted by the basic laws of physics to travel. No future technology ever closes this particular gap. No clever engineering ever shortens it either. The door is held shut by distance, and distance is the one thing engineering has never once found a way around. Consider what that means, practically and daily, for the people actually still responsible for operating this spacecraft, even now, after all these decades of quiet, patient, careful work. Every command sent has to account in advance for an entire day passing before any confirmation comes back that the command was even received correctly, let alone carried out successfully. You cannot course correct in real time. You cannot watch something start to go wrong and intervene immediately. By the time you see the first sign of trouble, whatever caused it happened nearly a full day earlier, and whatever you decide to do about it won't be known, on the other end, for almost another full day after that. That's a strange way to operate anything at all if you actually sit with it for more than a moment. Every single decision made about that spacecraft is a decision made about its recent past, not its present, sent forward into what will become its near future, arriving too late to matter, for whatever is actually happening to it right now. The conversation between Earth and Voyager 1 has never once, in nearly 50 years, happened in real time. It has always been a conversation conducted entirely in letters, each one taking the better part of a day to arrive, with no possibility of ever speeding up the mail. I think about the people who've worked on this mission for decades, some of them since before the spacecraft even launched, having spent their entire careers inside a rhythm this deliberately unhurried, checking in on a machine that answers, at best, once a day, and only ever about something that already happened yesterday. There is no version of their job that involves urgency in the ordinary sense. Urgency requires the possibility of a fast response, and no matter how urgently you might want to fix something, the fix cannot arrive sooner than the physics of the situation allows. Patience isn't a virtue in this line of work. It's simply the only available option, the one condition of employment nobody gets to negotiate around, however senior they eventually become. And this is still, by the standards of the rest of the universe, an extremely short delay. 23 hours is almost nothing, compared to the corridors this whole exploration has spent time inside already. Years for nearby starlight, centuries for more distant stars, millions of years for the nearest galaxy, longer still for almost everything else. Voyager 1's delay is the shortest, most human-scaled version of a pattern that only grows, at every larger distance, into gaps too large for a single lifetime to bridge at all. The spacecraft itself won't be able to keep sending signals back forever, regardless of how patiently anyone on this end waits. It runs on a small onboard generator that converts the steady heat of a slowly decaying radioactive material into electricity, a power source chosen specifically because it needed no sunlight, no maintenance, and no refueling to keep functioning for decades in the near-total darkness of deep space. That heat has been declining, slowly, predictably, since the day it launched, and at some point, likely sometime in the next few years, there will no longer be enough power left to run even its most essential instruments. The last message it ever sends will arrive here. Eventually, 23 hours or more after it was transmitted, and only afterward, only in the silence that follows, will anyone here know that it was the last one. There's something worth sitting with in the fact that the spacecraft itself won't know, in any meaningful sense, that its final transmission was final. It will simply keep doing what it has always done, sending its readings outward on schedule until the power finally runs too low to continue, at which point it will simply stop, mid-routine, with no closing statement, no announcement, nothing marking the moment as different from any of the thousands of ordinary transmissions that came before it. The ending, when it arrives, will look, from the spacecraft's side, exactly like every other moment that preceded it. If humanity ever does attempt to send a genuine message to another star system, hoping for any kind of response, the delay would no longer be measured in hours. The nearest star beyond our own sun sits a little over 4 light-years away, meaning a message sent today would take just over 4 years to arrive, and any reply, sent immediately upon receipt, would take another 4 years to come back. A conversation with our very nearest stellar neighbour, conducted as quickly as physics allows, would still take the better part of a decade just to complete a single exchange. Reach further out toward any star where a habitable world might plausibly exist, and the numbers stretch further still, often into centuries, sometimes considerably longer, depending entirely on precisely which distant star you happen to be hoping to reach. A message sent now, in the hope of ever receiving a reply, might not complete its round trip until long after everyone currently alive has been gone for generations, received, if it's received at all, by people who never sent it and never knew the ones who did. That's a genuinely strange kind of correspondence to imagine sending, one where you cannot expect to be present for the reply, where the entire exchange outlives the sender by design, not by accident. And yet radio messages have been sent this way already, deliberately, a small handful of times, aimed at particular stars, carrying encoded information about who sent them and why, with no expectation that anyone currently alive would ever hear back. An act of communication built entirely on trust in a future nobody sending the message will personally get to witness. Voyager 1 itself carries something similar, though it was never intended as a message expecting a reply at all. Bolted to its side is a golden record, an actual physical disc containing sounds and images meant to describe life on Earth to whoever, someday, somehow, might happen to find it, drifting silently long after the spacecraft has gone dark, long after its instruments have gone quiet, long after everyone who built it has been gone for longer than most of recorded history has lasted so far. It was never built to receive an answer. It was built for a kind of patience that doesn't require one. A message sent purely on the chance that distance, eventually, might be crossed by someone else entirely, someone not yet born, reaching in the opposite direction. I don't think there's a way to shrink any of this down to something more comfortable. The door stays shut for exactly as long as the distance demands, whether that distance is 23 hours or 4 years or 4 centuries, whether it's a spacecraft still faithfully answering, or a golden record drifting in permanent silence, addressed to no one in particular, waiting on a door that may never be opened by anyone at all. Nothing about wanting a faster answer changes the schedule even slightly, no matter how badly, how patiently, how hopefully anyone happens to be waiting on either side of it. The only thing that ever opens the door, eventually, if it opens at all, is time itself, spent waiting, quietly, on one side or the other, for whatever was sent to finally arrive. However long that turns out to take, however few of the people who sent it are still around to hear the answer afterward. None of this changes what already happened out there. It only changes when it becomes yours to know. That's the whole of it, really, stripped down to its simplest possible form, the one plain sentence sitting underneath every single chapter that came before this one, however differently each of them chose to dress it up and say it. That's worth saying plainly at the very end, because it's easy, after all this, after everything covered across every previous chapter, to feel like the delay itself is the strange part, the headline, the thing worth marvelling at above everything else. It isn't, not really, or at least not entirely. The strange part is smaller than that, and quieter, and easier to miss if you're looking for something more dramatic to hold on to. The strange part is simply this. Your knowing and the event itself have never once been the same moment, for anything, ever, not for a single instant in your entire life. And you've spent your entire life treating them as though they were, without ever quite noticing the substitution. Somewhere tonight, a place that has existed all along, doing whatever it's been doing for however long it's been doing it, is still, from where you're standing, waiting for its first appearance in your sky. Not because it is new at all. It might be older than anything else you've thought about today, older than the ground you're standing on, older than the sun itself, simply because you are only now old enough in light years for the news of it to have had time to arrive, measured not in birthdays but in the distance light has managed to cross since you happen to be standing here to receive it. I keep coming back to that phrase, old enough in light years, because it inverts something so basic about how age usually works that it takes a moment to feel the shape of what it's actually saying. You don't wait to grow old enough for a birthday, marked on a calendar, arriving on schedule regardless of where you happen to be standing. You wait to grow old enough, in a sense measured entirely in distance rather than years, for a piece of light that's already on its way, that set out long before you existed, to finally reach you, wherever you happen to be, whenever you happen to look up to receive it. Your age and the light's arrival are two separate clocks, running on two entirely separate systems, keeping two entirely separate kinds of time, and only occasionally, only by coincidence of geometry and distance and timing, do they happen to land on the same evening, in the same sky, at the same glance. There's nothing left to resolve here, and I don't think there's supposed to be. Every chapter in this exploration touched some version of the same basic fact, seen from a different angle, at a different scale, through a different piece of the sky or the interior of a star or the mathematics of a boundary, nothing can cross back out of. A protostar waiting for its first tick, its own clock not yet started, patient in a way that has nothing to do with virtue and everything to do with physics. A supernova's two messengers, arriving hours apart from the same instant, one racing straight out, the other stumbling through a maze of its own star's making. A galaxy's light, still crossing an unthinkable distance, arriving now, tonight, decades or millennia after it left some place that may no longer look anything like the light describes. A spacecraft, patiently answering a question a full day after it was asked, still faithfully doing its job long after most of what built it has changed beyond recognition. None of those chapters actually finish the thought. They couldn't. The thought doesn't finish. It simply keeps recurring, in star after star, in signal after signal, in every single glance upward for as long as anyone continues to look. I think that's why none of these chapters ever really ended cleanly, why each one seemed to trail off into something unresolved rather than snapping shut with a tidy final sentence. That wasn't a failure of the writing, or an accident of how each one happened to be constructed. It was, I think, the only honest way to treat an idea that genuinely doesn't resolve, that keeps recurring at every scale you look at it from, that refuses to hold still long enough to be wrapped up and set aside neatly. A tidy ending would have been a kind of lie, a suggestion that the gap between sending and seeing eventually closes, somewhere, for someone. If you just keep reading long enough, keep following the thread far enough towards some final, satisfying resolution. It doesn't. It never has, and there's no indication anywhere in any of this that it ever will. It's simply the condition every single one of these chapters was quietly describing from a slightly different angle each time, dressed up in a different topic, wearing a different star or a different boundary or a different silence, but never actually saying anything fundamentally different, underneath all that dressing. Even this chapter, the one meant to gather everything together and set it down gently at the very end, can't quite manage a real ending either, not one that actually closes anything meaningfully or ties anything into a final, satisfying bow. It can only point, one more time, at the same underlying shape that every previous chapter was already pointing at, and then stop talking, the way a room goes quiet after a sound has finally finished, not because the silence itself resolves anything, but simply because there's nothing left being said into it anymore. What changes, by the end of all this, isn't the universe. The universe was always doing exactly what it's doing now, before any of this was written, before anyone reading this existed to wonder about it, and it will keep doing the same thing long after everyone currently alive is gone. What changes, if anything changes at all, is simply this. You now know that the gap exists, that it's real, that it's built into everything you'll ever look at for the rest of your life, whether you think about it or not. That knowledge doesn't do anything, practically speaking, in any sense that would show up in your ordinary daily life. It doesn't shorten any wait, it doesn't speed up any signal, anywhere, for anyone. It doesn't bring anything closer that wasn't already exactly as close as it's always been, regardless of how much anyone might wish otherwise. It simply changes what it feels like to look up, now that you know what you're actually looking at. Not a single, coherent, shared present moment, but an enormous, uncoordinated arrival of separate pasts, each one finishing its own private journey on its own private schedule, converging purely by chance on this one particular night, this one particular glance, yours. I don't think that's a small thing, even though nothing about it changes anything you can point to or measure directly, anything you could hand someone else as evidence. Some part of you will keep looking up, on some ordinary night from now on evenings you won't even remember specifically afterward. And some quiet part of that looking will remember, without needing to think it through again from scratch every time, that everything up there is arriving late, permanently by design, and that lateness was never a flaw in the system. It was always simply how the system works. Consider what that phrase actually implies, if you sit with it directly, rather than just letting it pass by pleasantly. Somewhere out there, right now, something is finishing a journey that began before you were born, before your parents were born, before anything you'd recognize as history had happened yet, before the ground beneath your feet had settled into whatever shape it currently holds. It doesn't know it's arriving. It doesn't know anyone is standing here to receive it, waiting, unknowingly, exactly where it happens to be aimed. It's simply, finally, after all this time, showing up the way it was always eventually going to, regardless of who ended up standing here when it did. And somewhere else, something else hasn't started yet, still gathering itself, still waiting on whatever threshold it hasn't crossed, still years or centuries or millennia from being ready to send anything anywhere at all, its own clock not yet ticking, its own story not yet begun in any sense a distant observer could ever detect. Both of those things are happening tonight, in the same sky, at the same time, from where you're standing without either one aware of the other, without either one aware of you. Neither one is waiting for the other. Neither one is waiting for you. They were never going to arrive together, and they never will. And there was never a version of the universe, however differently arranged, where they could have. That's not a problem to solve, and I don't think it was ever really meant to feel like one at all. It's just the shape of the room you've been sitting in this whole time, the one where distance and light and time never quite agree with each other, and never will, and were never going to, no matter how patiently anyone sits with the question, no matter how many chapters get spent circling it from one direction or another. I think that's a genuinely fitting place to leave this whole exploration, not because the thought is finished, but because it was never going to finish, and pretending otherwise would have been its own small dishonesty. Some things are simply built to keep recurring endlessly, at every scale, in every direction, for as long as there's ever a universe left producing light, and a person left willing to stand still long enough to actually receive it. You're only now old enough, in light years, to be told.